Hello and welcome to another free code session. My name is Jason Bach and I want to keep hunting away at some of these bugs. The last one I have here is, I think, at least for this type delegator, is this type expected. And what the problem is that it's putting in this IteratorStateMachineAttribute, which if I actually go to, you'll see you shouldn't apply the IteratorStateMachineAttribute to methods in your code. So this is one that we actually want to filter out and not even have, at all. This is very VB specific. Anyway, so I think what we really want to do here is just say, if we find that something is using the iterator state machine, we just don't even want to include it at all. Okay. So I believe we could do something where we say get attributes. This, unfortunately, is very specific to method declaration, method symbol. So all we're saying is we just have one method declaration and we don't care what the attribute is, we just spit it out. I kind of like that because what we're going to do here is say get description for when iterator state machine attribute is present. Now, if I looked at the documentation here, it does have a constructor that takes a type. The type object for the underlying state machine type that's used to implement a state machine method. I'm thinking type of object sounds like just a good enough one for me, don't you think? So what is this in? Is this in system runtime compiler services? Okay, so we need to include that here, except not like that because that would be really bad. Okay, and just because I can't not do that, so we're going to say iterator state machine type of object, because nothing ever actually happens to it unless we do something. Okay, and so now we want to say is that assert that attributes does get description, we don't pass anything, should be equal to string.empty. Right there. Okay, now this should actually fail right now because we haven't removed this. Okay, now one failed because I bet it is putting in an iterator state machine. Okay, so now what we need to do is remove this. We can't emit attributes that are compiler generated, attributes that are not visible to the current compilation. What was them? Oh, e.g. intrinsic attribute. Not visible to the current compilation. Iterator state machine attribute. And we will grab the documentation here. Can I? No, I don't want view. Geez, stop it, please. Will that actually do the right thing? Yes, it will. Of course, you have to. No. There. Not intrinsic. Iterator state machine attribute. We just don't want that to be included at all. Okay, you got that. And it doesn't have any of these where it's not null, and it doesn't equal that, and it doesn't equal. I'm going to get the Boolean logic wrong. I always do. So it can't be null. It can't be equal to that, and it can't be equal to iterator state machine attribute. There. Now if we come back over here and we say run this, it should now be good. Oop. What did I tell you? Yep. Well, that was disappointing. Let's see what we can see here. I got the right attribute, that's for sure. Okay. Self. What is self? What is self? You may wonder. You may ask yourself. Okay, what is actually in here? An iterator state machine attribute. Okay. So, excuse me. What's the next statement? Let's do that again. I don't know if you're doing, there we go. Okay, so attribute class, no, attribute class, attribute usage class. Wait, self. What? What in the, am I looking at the wrong thing here? No, I think I'm looking at the right thing. That is the right thing. So, okay, hold on. That made no sense. Okay, let's say self 0. It's an iterator. Yeah. It's an iterator state machine attribute. So attribute class. Wait. We are getting, why are we doing this? Why are we looking at the attributes on the attribute class? Doesn't make any sense. All right. This, I don't get this. I don't get this at all. Why are we saying that we don't actually compiler generate? I bet we don't even have a test for this. We don't. I think I just added this. No, did I do this recently? No. But we can't do compiler generated attributes. So I think the same thing here is if we do this. 1, 2, 1, 0. Yeah, because we need to do that. Okay. This should also be equal to string. I'm really thinking this is wrong. Like we've wanted to do this and not equal to this and not equal to this. There we go. What happens when we run all these now? Well, they all pass. Okay. So I think that's what we're trying to do. We don't really know. Well, at some point I got to rerun all the tests. That's for sure. What I want to do here, though, before I continue, is I want to say var error emit error diagnostics, and this is equal to result.diagnostics where severity is equal to error to array. That's what we really want. We're not there yet. We're going to get there. Okay. So with the type delegator, we shouldn't see any errors now. Should being the operative word, or should not be seeing, you know. 0. Am I reading that right? Yep. Okay, we want to put the breakpoint here. All right, cool. So we've got that figured out. 167 updated, which attributes should not be included. Okay. Now let's go back and redo all of them and see where we are. Okay. 3,000 is my guess. Just because I don't have a better guess. Wow, 1,300. Okay, well, it's still not good. But we have definitely improved things. Okay, well what do we got in here? Com wrappers. Okay, so let's copy what looks like some common stuff. Okay, because these are both at the same thing. And we see a lot of type expected. I mean, not all of them are like that. Tuple make. What's this one? Let's deal with all the ones that are dealing with com wrappers. Because why not? There is a syntax error here. I wish this could kind of stay up, but that's okay. Anything else with com wrappers? Okay, so let's actually stop and let's address com wrappers. What in the world is that noise? Oh, it's upstairs. My wife is doing some cleaning. Com wrapper. Com wrappers, because you need more than one. Let's just do that because I don't want to pollute crap with stuff. If that made any sense. So, okay. So let's run this now and then grab the syntax tree, and see if we can figure out what the problems are. You know, this is something I should have done months, if not years ago. Realize that I wasn't compiling this and finding all these problems. You know, 195. So let's go to the output compilation. Get the syntax trees. We should have 2, and we do. Let's grab this, copy the value, put that in here, and scroll all the way up. Okay, so let's stop this now, and let's see on line 17. Com interface entry, compute vtables callback, because you know we need that. This is a public unsafe delegate bool. Argument evaluation for system runtime. Right. What is this saying? You're saying you need... Well... This is getting into some pointy stuff. No pun intended. Yeah, my wife's vacuuming now. That's wonderful. This is a delegate that returns this. This is a delegate that returns this, but it has some name here. Public unsafe sealed class. That's not a right name. That's a type, but not a name. Well, I think we're into pointer land. And I think what we're seeing here is some stuff that I don't ever run into that much at all whatsoever. So something in here. It's an abstract class. Create. I'm not saying great, I'm saying create. What is this trying to be? There's a comp interface entry compute vtables. And that is because this is abstract, so you can, but there's nothing in here that says comp interface entry. There's a struct here that does. There's a struct for a, yeah, there's a, it's like it thinks it needs to return a bool. I kind of get this one. That's coming from here. And it's because if we want to do a callback on it, this should also be a callback. Right? But com interface entry. The thing is, this should be very contained. This one's okay because we realize that this one doesn't need, like this is a, this is a type. This thing here. But we should be putting the name with all the underscores here, not the, this is the raw com wrappers. Compute vtables. There should be only 3 because the other ones you can't do anything with this. And then if you have a callback here, otherwise the return value is a com interface entry, which is this. Jeez. Wow. I feel like there's create object. This one should be pretty straightforward because we don't need to do anything that's like, there's an int pointer. We just do a func here. Release object should also be pretty straightforward. Okay. And it's all this stuff. Something with the generation, and I know the generation for pointer stuff gets really hairy because you have to create this argument for system runtime thing, and it's a pointer to the actual com interface thing. But why would you have an unsafe delegate bool where that is being passed in, but the name is this? And I think what I'm doing right now is I'm actually really delaying looking at anything to do with this because the pointer stuff was something I added in, and yeah, and I did that. I made some pointer stuff, you know, pointer archetype builder. Well, there's that. So that's where the value is coming in. That's where this other one's coming in. And then we get the class name. But the class name is wrong. Like if I come here, you'd think, like, are we saying flatten means that flattened options? Yeah, type name options. We're saying of that. Well, wait a minute. If it's a pointer type, we say to display string, replace point with pointer. Yeah, so it'd be that whole thing. Except then we say argument evaluation for that whole thing. So we're trying to flatten it, but okay, so the delegate bool there is there for a reason. The class name should be there as well, but we should be getting the projected name, and the projected name is a flattened version of it, right? Why is it not flattening it? We found the culprit, that's for sure. We've definitely found the culprit, but we don't know why. I've got to have some things in integrations, right, with pointer tests. You would think pointer tests. I have pointers, lots of pointers. Pointers, pointers, pointers. So what does that look like? Argument for delegate pointer of int. That's the delegate pointer for int. Well, so int doesn't get, so, okay, well, because I was a moron, I didn't do this far enough. I just said int. What happens if you have a com plus pointer? Then it all goes to crap. I bet if I come back to my code generation test, excuse me, it's that root beer in my I really wonder what this is sounding like on the mic. Yeah. Okay, so what we come in here is, what we do is, let's just say F10. Okay, and then we get, yeah, what we really want is all these undered, you know? Like if I say get projected evaluation delegate name, argument evaluation for type dot get name, type name option flatten. Okay, so let's set the next statement here again. Set next statement, okay. And then let's come into here. And let's see what happens. F10, but we should stop here. The options is a flatten. So we're going to say yeah. But what happens if the kind is a pointer type, which it is? So we're going to say self.to display string, which is not what we want at all. That is not what we want. Okay, the function pointer type, that kind of sort of works, but I bet it doesn't for complex ones. What I bet we really want is the get flatten named. Get flatten named of self. And then what's the type name? Why would I pass in type name options? See, now we're getting into type arguments. We don't have any type arguments, so it's going to still do like this. We really want to get to this. I think the flatten name is what I'm trying to do if you have a pointer. I'm sorry, not a pointer. If you have type arguments. Because if you don't have type arguments, then you just give the actual name back. Okay. The flat name is like flatten out the generics. It's not a good name. And I'm probably going to forget to do this. If I say include generics, then I'm actually saying literally include them. Flattening is saying I just want them to be part of a name. I don't want them to actually be, you know, with the type arguments. And you can see here that that's not what I kind of want to do with the pointer. I want it to be a flat, I want it to be a replace all the dots with underscore. That's what I really want to do with a pointer. Like I want to say here is replace all the dots with an underscore. That's what I want to do. And once again, it crashed. I'm probably going to switch to 2021. I can't record like this where I just barely notice all the time that something is dying. And that this has got to get fixed. So I'm going to have to go back to 2021 because that records just fine and I've never had an issue with it. So not good. Okay, so now if I do this, I get something like that. Okay. And now the arg name, what does that look like? Same thing. We get that. I'm kind of curious. Let's just see what happens if I do say go all the way now. 23. Unsafe code. The type or namespace name, com interface entry cannot be found. Really? Really? Com wrappers. That's, huh. Well, that's interesting. I'm saying that a lot here. So now what would happen is if I look at the output compilation and I look at the syntax trees, raw view, copy value, bring that over here, put that there. I thought I detected if you need unsafe that you have to do an unsafe compilation. I must be missing it. So now we've unsafe this whole thing. That's that name. And then we just have this. This is argument evaluation for this is argument. Okay. And you don't know what COM interface entry is, but it should be in system runtime interop services. It's technically within COM wrappers. So yeah, I'm gonna have to play with that too. What happens if you have a nested type and you're putting that in here? And that would be for anything. I mean, if you had a nested type somewhere, it's not just the namespace that matters. It needs to have the full type qualification there as well, I believe. So yeah. God, there is some. This is like one of those things I think is just. I cannot take the address of get a size of, or declare a pointer to a managed type. COM interface entry, but I don't think you know what COM interface entry is. So if I go to 23, yeah, I think this is just because it doesn't know what it is. It's getting confused as to, yeah. And I thought I had something in here that said, oh, that's right. Hold on. Yeah, I think I have to put something here. If you are using pointers, then you yourself have to have the compilation also allow unsafe. So I think that's what I'm saying here is, oops, compilation options is equal to new C# compilation options. And there should be something in here like unsafe, right? No, allow unsafe, true. Okay, takes one argument. Oh, I'm already passing this in here, aren't I? I believe that's what I'm already doing. Am I? Except I don't need that. There. Okay, so, and I should do this because I know I'm going to run into these things. I should just allow it. One more time. I know I'm way over time on this one, but let's just see if this reduces at least some of these errors. But yeah, I've got another problem, which is if you need to reference a type that's actually a nested type, you can't just have the namespace, you know. And now we're down to 17. And it's all because I don't think it knows what COM interface entry is. Okay, so I'm going to stop here. And then tomorrow, because it's getting late tonight, I think tomorrow I'll continue on this. I'm going to do some research on this with just nested type names. But because I now have the sneaking suspicion that when I'm getting the name of a type, I have to be very careful now with nested names. So thank you all for watching. Leave comments and questions below. See you in the next episode.